Hey guys, in this video we're going to learn about midsegments. Alright, so a midsegment is a segment that connects the midpoints of two sides. So we'll take triangle ABC for example, and if I were to draw a segment connecting BC and AC, and at that point of intersection, we'll call that point E and call the other point F. Now if E is bisecting BC, then BE would be congruent to EC. And then if F bisects AC, then AF and FC would be congruent as well. So then, if you know that there's a segment that's bisecting the two sides that's intersecting in the triangle, then we know that EF is the midsegment. Now, one of the properties of a midsegment is that if you have a segment that joins two sides at their midpoints, then it is parallel to the third side. So if I were to draw a segment that connects A, B, and BC, and at that point we have G and H, and we notice that at G and H it's bisecting the two sides it's interacting with. So then we can say that GH is the midsegment, and then GH is also parallel to the third side AC. Now another property of a midsegment is that if you have a segment that joins two triangle sides at their midpoints, then its length is half of the third side. So if we know that AC has a length of D, whatever that is, it stands for distance, and we draw a segment connecting A, B, and BC. Now if we know that Q and R bisects AB and BC respectively, we know that QR is the midsegment. Not only is QR going to be parallel to the third side, but the length of QR is half the distance of whatever this is. So if we know that, let's say, AC was 12, QR would be, 6. So we can say QR is equal to, whatever that length is equal to 1/2 of AC. Alright, in example 1 we're going to apply the midsegment theorem, and it says in each triangle MN and P are midpoints of the sides. Name the segment parallel to the given one. So CD is this side right here, and we have to find what side or what segment is going to be parallel to CD. Well, knowing that MN and P are midpoints of the sides of the triangle, so we can say CM to MD are congruent, those two segments are. We can say CP and PE are congruent, and we can say DN and NE are congruent. All different lengths, but the pairs where the midpoints are intersecting those the three sides, 1, 2, 3, we have two congruent parts on each side of the triangle. So now, knowing that information, if we're focusing on CD, that would be the side that we're looking at. So then, what segment would be parallel to the side of CD? Well, we notice that inside there's another triangle. So the focus point of our picture has to be PN. And if you look at PN, P bisects CE, N bisects DE, which makes PN a midsegment. And we just learned that if you know that this is the midsegment in your triangle, then this midsegment is going to be parallel to the third side. So CD is parallel to PN. In example 2, we're going to find the length of SR and FD, knowing information from the properties of midsegments. So right now, if we look at the diagram, we know that SR is inside of this triangle, and what R is doing is bisecting ED, and S is bisecting EF, which we know now that SR is the midpoint. So then we know that if we're trying to figure out the length of SR and FD, well, we need to figure out what the value of that variable is first. But we know that SR is the midpoint, so therefore SR is half the length of FD. So we have to take that concept and write an algebraic equation to represent that idea. So SR is the midsegment, that's what we declared. Since we know that SR is half the length of FD, now we can substitute what we know. So we know that the length of SR is currently 2x minus 14. The length of FD is x plus 2. So substitute in our corresponding information. So SR becomes 2x minus 14, and that length, whatever it may be, is equal to half of whatever FD is, so it's x plus 2. Now we kick back in Algebra 1, distribute the 1/2 to the binomial. So you get 1/2 x plus 1. Then we're going to add 14 to both sides, trying to solve for the value of x. We get 2x is equal to 1/2 x plus 15. So we're going to bring the 1/2 x to the other side of the equation. You get 3/2 x equals 15. Divide both sides by 3/2. X is equal to 10. Now we're not done. We found the variable x, or the value of the variable x. Now we have to figure out what the length of SD and FD are. So we substitute in 10 into our expression that is represented by 2x minus 14 for SR. So 2 times 10 minus 14, we get 20 minus 14. Therefore, S is equal to 6 units. And since we know SR is the midsegment, FD, we just double the length of SR. So FD has to be 12 units.